Hello, in this video, we are going to take a look at this theorem that tells us about the possibilities for a radius and interval of convergence for a power series. So given a generic power series, c sub n x minus a to the n, there are going to be three possibilities. The first possibility is that the series converges for all x. This means that the interval of convergence is going to be negative infinity to infinity, and the radius of convergence is r equals infinity. How we get this situation is when we run the ratio test and get that the limit as n goes to infinity of that a sub n plus 1 over a sub n comes out to be 0. And 0 is less than 1. So the ratio test says it did not matter what x was. This limit is always 0. The example from the last video where we got this was n equals 0 to infinity, 1 to infinity, of x to the n over n factorial. Does not matter if it's 0 or 1. The second possibility is that the series diverges for all x except at the center x equals a. So at the center, it will always converge. But it diverges everywhere else. In this situation, we have that the interval of convergence will be just the center. And the radius of convergence is 0. How we get this situation is we run that ratio test and get the limit as n goes to infinity of a sub n plus 1 over a sub n comes out to be infinity. Infinity is always greater than 1. So by the ratio test, it's diverging for everything except when our series is all zeros. And our series is all zeros at the center. The example we saw of this in the last video is the series n equals 1 to infinity of n factorial times 3x plus 2 to the n. And then the last case we can get is that there is a real number r bigger than 0 such that the series converges for absolute value of x minus a is less than r and diverges for the absolute value of x minus a bigger than r. Once, how we end up with this is, again, running the ratio test. And we'll get that the limit as n goes to infinity of the absolute value of a n plus 1 over a n is equal to possibly some number c times x minus a. We then set that less than 1 and we can solve. In particular, absolute value of x minus a would be less than 1 over c. C is going to be positive because we were taking the limit of an absolute value. And we then have our interval of convergence. We have our radius of convergence as well. So the radius will be r. And the interval of convergence will be our center a minus r to a plus r. But there are actually 4 ways this can happen. Because remember, from the example we had where something like this happened in the last video, at a minus r and a plus r, these are actually the things that the ratio test can't tell us about. So at these 2 values, we need to test them with another test. So we're going to take those values, a minus r and a plus r, and plug them into series, and we'll either get both of those series diverge, meaning a minus r and a plus r are values of x where the power series diverges. We can get one converges and one diverges. We can get that in either way. Or we can get that both converge. This would be both diverge, and this would be both converge, using our interval notation. How do we tell what we have? As stated, we plug a minus r and a plus r into the series and use a different, meaning not the ratio test, and not the root test either, different test to determine convergence or divergence. Most of the time, the 2 tests you'll end up using are a p-series and an alternating series. So those are most often the 2 tests that you'll end up needing to use to tell if the interval has those endpoints converging or those endpoints diverging. So we have three situations that we get for a power series is either the interval of convergence is everything, the interval of convergence is just the center, or we have this interval that goes over just some real numbers with a radius of r, and then we test the last points to tell exactly what our interval of convergence is.